Have you ever like stopped and thought about how those apps you use, the ones you rely on all the time, how they get updated without you even noticing?
Yeah.
Or like how they seem to just magically recover when something goes wrong? It's like there's this, I don't know, like an invisible hand keeping everything running smoothly behind the scenes.
Right, right. It really is quite remarkable.
Yeah, and that invisible hand in many cases is something called Kubernetes deployments.
Exactly.
And that's what this deep dive is all about. We're going to try to understand just how they work.
Absolutely. Kubernetes deployments are, I would say, essential to how we manage modern applications, especially when we talk about those containerized apps that everyone's using these days. They're like the secret sauce that ensures everything keeps ticking along smoothly.
Yeah, they really are the backbone of keeping things running.
Yeah.
And when we talk about like all the information we're using for this deep dive, we've been looking at articles, explanations, all sorts of stuff that really gets into the nuts and bolts of Kubernetes deployments.
Yeah.
And what's really amazing is the scale of the problem that Kubernetes and especially deployments actually solve.
Right.
Imagine like trying to manually manage like the deployment and scaling and updates for even a small number of application components.
Oh, yeah.
It'd be a nightmare,
It
right?
would be a complete and utter nightmare. Yeah, you're talking about constant manual intervention, a huge potential for human error, and trying to keep track of so many moving parts.
Yeah,
It just wouldn't be
it
sustainable.
would be impossible.
Yeah. Before we had these sophisticated tools like Kubernetes, managing the life cycle of containerized applications was, well, let's just say it was very, very manual,
Yeah.
very error prone. And that's where Kubernetes deployments come in. They offer this, I guess you could say, elegant, automated solution to all of that complexity.
Yeah.
Instead of giving Kubernetes step-by-step instructions like you would with, a traditional script, you basically describe the outcome you want for your application.
Okay. Yeah.
You say, this is what I want my application to look like. This is how many instances I need. This is the version I want to run. And the deployment controller, this is a key part of Kubernetes, takes over from there. It figures out how to make that happen and make sure it stays that way.
So it's less about telling Kubernetes how to do things and more about telling it what you want the end result to be.
Precisely. It's like, imagine you're setting up chairs for a conference or something.
Okay.
The old imperative way of doing things would be to say, okay, take this chair, put it here, take another chair, put it 2 feet to the right, and you'd have to give instructions for every single chair.
Oh, yeah.
But with a declarative approach, like what Kubernetes deployments use, you simply say, I need 100 chairs arranged in rows of 10, and you're done. You've described the outcome, and someone else, in this case Kubernetes, takes care of all the details of actually making that happen.
Oh, that makes a lot more sense.
Yeah, and for your applications, this means you can just declare, I need 5 instances of my app running at version 1.2.3, and the deployment will handle everything else, creating containers, making sure they're healthy, updating them when a new version comes along. All that stuff is taken care of automatically, and this has huge benefits, obviously.
Yeah.
You get automation, you get consistency, and you greatly reduce the chance of human error creeping into those really critical processes.
So what are the key, I guess, abilities that deployments have that actually make them able to do all this? Like, how do they actually achieve that desired state that we define?
So there's a bunch of functionalities that are really important here. First, you've got the ability to deploy and manage multiple copies or replicas of your containers. These are typically organized into what we call replica sets, and deployments handle all the work of managing those replica sets. Then you have updating, which is super critical. Deployments handle updating those containers to new versions when you want to roll out a new release of your application. But, and this is equally important, they also handle rolling back to previous versions if an update goes wrong.
Oh, nice.
It's like an undo button for your deployments.
That's good. That's important.
Yeah, and you wouldn't want to be without that, especially in production. Then there's scaling. Deployments let you easily adjust the number of running instances based on demand. So if your app is suddenly getting a lot more traffic, you can just scale up the number of replicas and handle that load without any problems. And you can even pause and resume deployments if you need to, which is really handy for certain situations. But I think the most important thing is that deployments are constantly working to make sure that the exact number of application instances you've specified are actually running.
Right.
And if something goes wrong, like a container crashes or a server fails, the deployment will automatically kick in and try to bring what app back to that desired state. That's that self-healing capability we mentioned before. It's a real lifesaver.
Yeah, it's like it's constantly checking that everything's okay.
Exactly.
So to actually set that desired state, it all starts with a configuration file, right?
Yes, exactly.
What does that look like?
So you define your desired state in a file called a manifest, and it's usually written in a language called YAML. You can also use JSON, but YAML is more common. Think of this file as the recipe or the blueprint for how your application should be deployed. It tells Kubernetes everything it needs to know.
So it's like giving Kubernetes the instructions.
Exactly.
Okay, so what are the must-have sections in this YAML file? Like, what information absolutely needs to be there for Kubernetes to understand what we're trying to do?
All right, so there are several key sections. First, you'll have API version.
Okay,
This tells Kubernetes which version of its API you're using to define the deployment. For most deployments, you'll be using something like appsv1. Then you have the kind field, which just clearly states that you're defining a deployment. Next is metadata.
okay,
And this holds information about the deployment itself. So things like its name, which has to be unique within a specific area of your Kubernetes cluster called a namespace.
got it.
And then you have labels, which are super important. Think of them as customizable tags that you attach to Kubernetes objects. They're used for organization and selection, so you can easily identify and group your resources.
So, like, you could label your app with things like its function, the environment it's running in, maybe like production or testing or even its version.
Exactly. And those labels are key to how deployments and other Kubernetes components figure out how to interact with each other. Then we get to the really meaty part of the configuration, the spec section.
Okay,
This is where you define the actual desired state of your application. So one of the first things you specify is replicas, which is just the number of identical copies of your app that you want running at any given time. Then you have selector, which is how the deployment figures out which pods belong to it. The selector uses those labels we talked about to find the right pods.
oh, so the deployment's basically saying, I'm looking for all the pods that have these specific labels, and those are the ones I'm going to manage.
Right, exactly like that.
Okay,
It's kind of like having an address to find the right components. And within that spec section, there's this really important field called template.
okay,
This is where you define the configuration for the pods themselves. It's like a blueprint for each individual instance of your application. And inside the template, you have metadata, where you, again, define labels, but this time it's for the pods. And these labels have to match the selector that we defined in the deployment.
right, okay.
Then within the spec of the template, you describe the actual containers that are going to run inside the pod. So you specify things like the image to use, which is where your application code lives, the network ports that your app exposes, any resource requirements like CPU and memory, environment variables, volume mounts, and really importantly, health checks.
Health checks.
Yeah, you need to tell Kubernetes how to check if your application is actually healthy and running correctly. There are two main types of health checks: liveness probes and readiness probes.
Oh, okay.
Liveness probes check if the container is still running. If it's not, Kubernetes will try to restart it. Readiness probes, on the other hand, check if the container is ready to handle incoming traffic. If it's not ready, it'll be removed from the load balancer until it is. You can also specify affinity rules, which influence where the pods get scheduled within your cluster. And finally, within the main spec of the deployment, you define the strategy that Kubernetes should use when it updates your application. The most common ones are rolling update, which tries to minimize downtime, and recreate, which is simpler but might cause a brief interruption.
Wow, that spec section sounds like it has a lot going on.
Yeah, it's pretty packed with information.
So once you have this YAML file all written out, how do you actually tell Kubernetes to go ahead and create the deployment?
You use the command line tool kubectl, which is like the Swiss Army knife for interacting with Kubernetes.
Okay,
And you run the command kubectl apply niasf filename.yaml, where filename.yaml is the name of your manifest file. The apply command basically tells Kubernetes to take the configuration defined in your file and apply it to the cluster.
okay.
And the nice flag just specifies which file to use. And what's really neat here, going back to that declarative nature, is that kubectl apply doesn't just blindly execute commands.
Yeah,
It actually looks at the current state of your cluster and compares it to what's defined in your YAML file. If the deployment doesn't exist yet, it'll create it. If it does exist, it'll only make the changes that are necessary to bring the actual state in line with your desired state.
so it's not like saying create 3 pods. It's more like ensure that there are 3 pods matching this description.
Exactly. And while there is a way to create deployments using more imperative commands, like kubectl create deployment, the declarative approach using YAML is definitely preferred, especially for anything beyond really simple scenarios. These YAML files can be stored in version control systems like Git, which is a core principle of what's called GitOps.
Okay.
This allows you to track all the changes to your deployments over time, makes it easy to roll back if something goes wrong, and helps you keep things consistent across different environments. And as we mentioned earlier, those labels and selectors are absolutely critical for making this all work.
Yeah.
The labels defined in the pod template have to match the selector in the deployment, otherwise the deployment won't be able to manage those pods. It's like having the wrong address on an envelope. It won't reach its destination.
Right, right. Okay, so the deployment knows which pods belong to it, but how does it make sure that the right number of those pods are always running, and what happens if one of them fails?
This is where another Kubernetes resource called a replica set comes into play.
Replica set, yeah.
Yeah, when you create a deployment, it doesn't actually directly manage those individual pods.
Okay.
Instead, it creates and manages one or more replica sets. And the job of a replica set is to make sure that a certain number of identical pods are always running. The deployment controller tells the replica set how many replicas there should be, and the replica set takes care of actually creating and managing those pods.
So it's like delegating the task.
Exactly. The deployment's the manager and the replica set's the worker.
Okay.
And a deployment controller is constantly monitoring how many pods are actually running and comparing that to the desired number that you specified in the deployment. If there are fewer pods than there should be, maybe because one crashed or a node went down, the deployment controller will tell the replica set to create new pods to get back to the target number.
And if there are too many pods?
Then it'll tell the replica set to scale down. And this whole process happens automatically without you having to do anything. That's what makes Kubernetes so powerful.
That's the self-healing part we were talking about earlier.
Exactly. And those liveness probes that we talked about before are also important here.
Right.
If a liveness probe fails, Kubernetes will try to restart the container, and if that doesn't work, it might even terminate the entire pod and let the replica set create a new one.
That's a pretty robust system.
It is.
So let's move on to updates. How do you actually deploy a new version of your application without causing any downtime for your users? I know deployments are supposed to be really good at handling this smoothly.
Yeah, they are. Again, the key is how deployments and replica sets work together. Let's say you've built a new version of your application and you've created a new container image for it.
Okay.
You would update the image field in your deployment's YAML file and then apply that change using kubectl apply. But when the deployment controller sees that change, it doesn't just immediately replace all the existing pods.
Okay.
Instead, it does what's called a rolling update. It'll create a brand new replica set for the new version of your application, and then it'll gradually scale down the old replica set while simultaneously scaling up the new one.
Oh, so it's like a carefully managed handover.
Exactly, and this ensures that there's always at least some version of your app available to users, minimizing any potential disruption.
Makes sense.
And this is all handled by the default rolling update strategy. But you can also fine-tune this process by tweaking a couple of parameters in the deployment stack. You've got max unavailable, which controls how many pods can be unavailable during the update, and max surge, which controls how many extra pods can be created above your desired number of replicas.
So those parameters let you control how aggressive or conservative the rollout should be.
Exactly. And Kubernetes also uses those readiness probes we talked about to make sure that the new pods are actually ready to handle traffic before the old ones are taken down.
So it's making sure that those new pods are healthy and ready to go before switching over.
Exactly.
Now, what happens if you do a deployment and something goes wrong? Like, is there a way to quickly revert back to the previous version?
Thankfully, yes. Kubernetes deployments have a really nice rollback mechanism. Kubernetes keeps track of your deployment revisions, which are basically snapshots of your configuration at different points in time.
Oh, that's handy.
It is. So if a new deployment causes problems, you can easily revert to a previous known good version. To go back to the immediately previous version, you can just use the command kubectl rollout undo deployment name.
Okay.
And Kubernetes will handle everything. It'll scale down the current problematic replica set and scale up the one from a previous deployment. You can also roll back to a specific revision if you need to, using the toRevision flag and specifying the revision number you want to go back to. And to see the history of all those revisions, you can use kubectl rollout history deployment name.
So you've always got that safety net if things go wrong.
You do.
That's great. Now, what about when your application needs to handle changes in demand? Like, what if you suddenly get a big spike in traffic? How do deployments help with scaling up to meet that demand and then scaling back down when things settle down?
So deployments make it super easy to scale the number of pods up or down to match your application's needs. You can do this manually with the kubectl scale deployment command.
Okay.
Just specify the new number of replicas you want, and Kubernetes will take care of the rest. But you can also scale things declaratively by just changing the replicas field in your YAML file and then applying it with kubectl apply.
Right.
This keeps everything in sync with your configuration management system. And then Kubernetes also has this really cool feature called horizontal pod autoscaling, or HPA.
horizontal pod autoscaling.
Yeah, HPA lets you automatically scale the number of pods based on things like CPU utilization, memory consumption, or even custom metrics that you define. You can set up rules that say things like, if CPU usage goes above 80%, add more pods, or if memory usage drops below 50%, remove some pods.
So it's like having an autopilot for scaling.
Exactly. And this can be a huge time saver and really helps you optimize your resource utilization. The HPA controller constantly monitors those metrics and adjusts the number of replicas as needed. And of course, whenever the number of replicas changes, the deployment controller tells the replicate set to make the necessary adjustments, either creating new pods or terminating existing ones.
So it all comes back to that same pattern, with the deployment setting the target and the replica set doing the actual work.
Right. They work together really well to ensure that your application is always running at the right scale. Now, earlier we talked about the rolling update strategy for doing updates, but are there any other ways that deployments can handle updating an application? Yes, there are definitely other strategies you can use. While rolling update is the default and often the best choice for production environments because it minimizes downtime, there are times when you might want to use something else. One common alternative is the recreate strategy. With Recreate, all the old pods are terminated before any new ones are created. So you will have a brief period of downtime during the update, but it's a much simpler approach. It's often used in development or testing environments where a short outage isn't a big deal.
So rolling update is the smooth transition, and recreate is more of a clean break, even if it means a little downtime.
Exactly. And beyond those two built-in strategies, there are a bunch of more advanced deployment patterns that people use, although they might require some extra configuration or tools.
Okay.
Things like blue-green deployments, where you have two identical environments running side by side and you switch traffic between them.
Oh yeah, I've heard of those.
Then there are canary deployments, where you gradually roll out the new version to a small group of users before going full scale.
Yeah, that's a good way to test things out in the real world.
And there are ramped slow rollouts, which are similar to Canary, but with more gradual and controlled rollouts. And then there are shadow deployments, where you send a copy of your traffic to the new version without actually affecting the users. And finally, there's A/B testing, where you run two different versions simultaneously and compare their performance.
Wow, that's a lot of different strategies.
It is. Choosing the right strategy really depends on your specific needs and risk tolerance, but it's great to have so many options.
It is. So to summarize those different strategies, we could say that with rolling update, you're gradually replacing old pods with new ones, which typically results in zero downtime, but can be more complex to configure. With recreate, all old pods are terminated before new ones start, which is simple, but means some downtime. Then you have blue-green, which uses two identical environments and a traffic switch, giving you zero downtime and easy rollback, but requiring double the resources. Canary involves gradually rolling out to a small subset, which lowers the risk, but needs careful monitoring and traffic management. Ramp slow rollouts are also gradual but have more thorough monitoring. Shadow deployments send a copy of traffic to a new version without affecting users, good for testing with real traffic but needs a service mesh. And A/B testing runs two versions with traffic split, which is great for data-driven decisions but can get pretty complex.
Exactly. That's a great summary.
Now, we've talked about how deployments ensure the right number of pods are running and how they handle updates, but how do they actually keep an eye on the health and status of your application to make sure everything is working as it should be?
So that all boils down to continuous monitoring, which relies heavily on those health checks we talked about, the liveness probes and readiness probes.
Right, right.
Remember, the liveness probe checks if a container is still running. If the probe fails, Kubernetes will restart the container. The readiness probe checks if the container is ready to handle traffic. If that fails, the pod will be removed from the service endpoints until it's healthy again. And the deployment controller is always watching the status of those replica sets, making sure that the number of pods that are reported as ready matches the number that you specified in the deployment.
So if something's not right, the deployment controller will step in and take action.
Exactly. It might tell the replica set to create new pods or terminate some existing ones. It's all about maintaining that desired state and making sure your app stays healthy and available. And as a user, you can always check the status of your deployments using the kubectl rollout status command, which gives you real-time feedback on what's going on.
So to wrap things up, it sounds like Kubernetes deployments are really the unsung heroes of modern application management.
They really are.
They handle so much of the complex work involved in deploying, scaling, updating, and keeping our applications running smoothly.
Yeah, they're like a built-in operations team that never sleeps. They provide this really powerful, declarative way to manage your applications, ensuring high availability, resilience through self-healing, and really critical safety features like rollbacks.
So it's not just about making deployments easier. It's about making our applications more reliable and resilient.
Absolutely. And knowing all of this about how Kubernetes deployments work, how they orchestrate those complex processes of updates and recovery, I'm curious, what possibilities do you see for making your own projects or the systems you use every day even more robust and efficient?
It's amazing to think that all this is happening behind the scenes every time we update an app on our phone.
It is. It really makes you appreciate the complexity involved in keeping everything running smoothly.
Absolutely. If you're interested in learning more about this, I'd highly recommend checking out some examples of Kubernetes deployment YAML files. You can find tons of them online. Or maybe dive deeper into those different deployment strategies that we discussed. There's a lot to explore, and understanding Kubernetes deployments is a really valuable skill these days.
Agreed. It's a fascinating area of technology, and it's only going to become more important as more and more applications move to the cloud.